Hello and welcome to MATLAB Programming for Numerical Computations course. We are in module 1, which is Introduction to MATLAB Programming. Today we are going to revisit lecture 1.2, where we had discussed some of the array operations in MATLAB. We are going to take one simple example to look at how the array operations can be fairly powerful tool in MATLAB. So, the example that we are going to take is basically on marks that are earned by 6 students in 4 different courses. The courses are mathematics, programming, thermodynamics and mechanics, and the marks that are obtained by the 6 students are listed over here. We are going to undergo certain computations that we did in the previous lecture. We are going to revisit them with this specific example. So, the computation that we are going to do is, first we will create a matrix called all marks, which will contain the marks for the first 3 courses. The 3 courses are math, programming and thermodynamics for all of the 6 students, and then when the mechanics marks come in from the teacher for mechanics, we are going to add those marks or append those marks to the matrix that we have formed. If you recall what we said in the previous lecture, basically this is going to be a matrix which has 6 rows and 4 columns, and therefore it is going to be a 6 by 4 matrix after we have appended the mechanics marks. Once we are done at appending the marks for the mechanics course, we are going to do several computations. First is going to be scaling the marks for the various for the mechanics course. We are going to extract the marks of Chetan and give it to him, as well as calculate his total marks. 2 of our students, Deepak and Farah, are the best students. So, we are going to extract the marks for the first 3 courses for these 2 students. We are going to calculate average marks, and we are going to scale all the marks out of 10. And we are going to use one of the matrix fundas for this in matrix multiplication. So, if you have a matrix of this sort, A, B, C, D, E, F, so we have 3 rows and 2 columns, and we multiply this with a diagonal matrix of this form. We are post multiplying with the diagonal matrix. What is going to happen over here is that the number 2 is going to multiply with the first row, and the number 0.1 is first column, and the number 0.1 is going to multiply with the second column, and this is the result that we are going to get. You can just simply do this matrix multiplication and see this for yourself. So, A multiplied by 2 plus B multiplied by 0 is going to be 2A, A multiplied by 0 plus B multiplied by 0.1 is going to be 0.1B, so on and so forth. Okay. So, if we want to scale all the marks out of 10, this is the kind of computation that we need to do. Remember that at this stage the marks for the 3 lectures are going to be out of 100, whereas eventually the marks for mechanics is going to be out of 50. So, that is what we are going to do in MATLAB. So, let us go over to MATLAB to do this array operations. Okay. So, rather than typing out all this stuff, I have already created a file which calculates the marks for the 3 courses for all the 6 students, and we have also given mechanics marks in another vector called mech marks. Okay. So, let us type all marks, let us type mark list, and when we execute this, we are going to get all marks and mech marks as the 2 vectors. So, let us type all marks. Okay. So, these are the marks for 6 students in the 3 courses, and mech marks are the marks for all the 6 students in mechanics course. Okay. Now, what we want to do is we want to append mechanics marks to all marks array. So, I will do this all marks equal to all marks comma mech marks. Okay. I am going to get an error over here, but let's try this out and let's see what happens. The error that we get is error using horizontal catenation. That means what we are trying to do is we are trying to put a 1 by 6 array besides a 6 by 3 array, which is something that we cannot do. So, we have this particular box over here, and we want to put this box next to it. That is something that is not possible in MATLAB. What we need to do is we need to transpose this particular array, and once we transpose that array, we are going to put it next to the all marks array. So, let us try and do that, and in order to do that, I will just clear the screen first. Okay. Transposing mecmarks is the command for that is mecmarks dash, that is going to transpose the mecmarks, which is going to result in a 6 by 1 array. 6 by 1 array we can catenate it with a 6 by 3 array, and that is going to result in a 6 by 4 array. Okay. So, when we try to do that, we are now going to get our all marks as the marks for 6 students in the 4 courses, and this is what we wanted as the result of the first computation step. At the end of the first computation step, we wanted to append the marks for mechanics course whenever we are to the all marks array whenever we receive. Okay. The next thing that we want to do is we want to scale the marks for mechanics by to marks out of 50 instead of marks out of 100. So, in that case, what we need to do is mecmarks equal to mecmarks multiplied by 0.5. That is going to basically scale the marks out of 50 instead of out of 100. Okay. Because this is a scalar multiplication with a vector, we can actually do this, and this is not going to be a problem, and we are going to get the marks in mechanics out of 50. So, this is going to be the marks in mechanics out of 50. Okay. And now what we want to do is we want to now replace the last column with the actual scaled marks. Okay. So, how do we access the last column? All marks, last column is going to be the 4th column. Okay. So, it is going to be 1 to 6 all the rows comma 4th column. Okay. So, this is going to access basically the last column and all the rows in that column. So, the rows is going to be the first element in the reference, and the column is going to be the second element in that reference. Okay. If we type this, let us see what we are going to get. We are just going to extract that particular column. Okay. So, when we type this, this is what is we are going to extract. Okay. What we want to do is not extract, but assign the mech marks that were shown over here. That is what we want to assign to that particular array. So, what we are going to do is all marks colon comma 4. Remember, if we just use colon without any numbers on either side in an array notation, that means the entire column, all the rows in that particular column. So, that is going to be equal to mecmarks prime, because we want to transpose that multiplied by 0.5. Okay. And when we do that, we are going to get all marks as seen over here. Okay. Now, the reason why we are getting this in not an integer form, but a real number form is because we have 2 marks over here, 36.5 and 45.5, which are real numbers. If this was a programming language such as C++, we would have to define all marks as a real number vector or a real number array, which is something that we do not need to do in MATLAB. So, MATLAB is a higher level programming language that itself takes care of all this conversion from integer into double precision into integer, so on and so forth. All the numbers are by default defined as double precision numbers in MATLAB. So, we do not really have to worry about defining or predefining any of the arrays in MATLAB. Okay. The next thing was to extract the marks of Chetan. So, I have named the 6 students A, B, C, D, E, F, so that it is just easier for us to note to extract or to find out what particular row that particular student belongs to. So, Chetan is row number 3. So, we wanted to extract the marks for Chetan. So, I will say Chetan marks equal to all marks. Okay. We want to extract row number 3 now. So, row number 3, and and all the columns from that row number 3. So, we can say 1 colon 4 because we have colon we have 4 marks, or I can just put colon over here because we want that entire row. Okay. When I do that, I am able to extract the marks for Chetan. Okay. So, these are the marks for Chetan. Now, I wanted to also calculate the total marks for Chetan. All I need to do is use the command sum Chetan marks, okay, and I am going to get marks, the sum of the total marks for Chetan, which is 224.5. Okay. So, that is what I am going to get over here. Now, what I wanted to do is for Deepak and Farah, I wanted to get their marks, okay, for the first 3 courses only. So, Deepak is in row number 4, Farah is in row number 6, and I wanted column number 1, 2 and 3. Okay. How do I do that is I will clear the screen over here, all marks. Okay. I wanted row numbers 4 and 6. So, in square brackets I will put rows number 4 and 6, okay. Then separated by comma, and I will put all the columns that I need, and the columns that I needed are 1, 2 and 3. When I put that and type enter, I am going to get the marks of Deepak and Farah in the 3 courses. So, I will just type all marks again so that we can confirm what we have gotten. So, the marks for Deepak are over here, which we have gotten in the first row. Marks for Farah are over here, which we have gotten in the second row. Okay. So, this is how we are able to extract a sub array from any array or matrix in MATLAB. Okay. So, now let us next step that we wanted to do, let us go over and find out. Okay. Next, what we wanted to do is to calculate average marks obtained in each of the 4 courses. Okay. And the way to compute average is in MATLAB is using the command mean. So, let's do help mean. Okay. And it is, let us read, S equal to mean x is the mean value of element x if x is a vector. Okay. For matrices, S is a row vector containing mean values of each column. Okay. So, what that means is that if we have a vector, for example, Chetan marks was a vector. If we do mean Chetan marks, we are going to get the average of marks of Chetan, okay, in all the 4 courses. Okay. Instead, what we wanted to do is we wanted to get the mean in each column of all the 6 rows in each column of all the 6 students in column number 1, likewise all the 6 students in column number 2, 3 and 4. That is exactly what the command mean does if it operates on an array, which means that it is going to mean over the first dimension. The first dimension is the row dimension. So, it is going to mean the first guy with the second guy with the third guy with the fourth guy with the fifth guy and the sixth guy in column number 1. It is going to repeat the same operation for column number 2, it is repeat the same operation for column number 3 and repeating the same operation for column number 4 also. So, let us try that mean of all marks. When I type that and I press enter, this is what I am going to get. So, this is the mean of all students in the first course, that is math course. So, the average marks in mathematics is 53.5, average marks in computers is 52.2, average marks in the third course is 61 thermodynamics, and the average marks in mechanics is 31.3 for all the 6 students. Okay. Now, let us say we wanted to get the sum of marks for each student. We can do sum. Let us do help sum over here. Okay. And what we see over here in one of the things in the help section is S equal to sum x comma dimension sums along the dimension dim. Okay. So, let us go back to the all marks array over here. So, what we wanted to do is we wanted to sum over all the columns. So, sum over column 1 plus column 2 plus column 3 plus column 4. Okay. So, column is the second dimension, row is the first dimension, column is the second dimension. Recall when we said all marks I comma j, I was the row, j was the column. So, I is the first dimension, row is the first dimension, j is the second dimension, column is the second dimension. So, we wanted to sum over each and every column. So, we want to use the command sum all marks comma 2, okay. That is going to sum over the columns for all marks. So, we will get the sum of marks, the total marks for each and every student, okay. And when we do that, we are going to get, so first guy is the total marks for Amit, second guy is the total marks for Bhavna, third one is total marks for Chetan, so on and so forth. So, we can see that these are the total marks for each student, okay. So, this is what we obtain. The final thing that we wanted to do was to scale the marks out of 10, okay. Okay, recall that the first 3 guys are marks out of 100 and the last guy is marks out of 50. So, remember the matrix operation that we wanted to do? The same matrix operation now we need to do with a 6 by 4 matrix, that is matrix of 6 students and 4 lectures. We wanted to scale it to 1/10, 1/10, 1/10 and 1/5, okay, because the mechanics marks is out of 50 and not out of 100. So, what we want to do is we want to create a diagonal matrix of 4 rows and 4 columns. First guy is 0.1, second guy is 0.1, third guy is 0.1 and the last guy is 0.2, because we want to scale out of 50 to out of 10, okay. So, how do we create that? Let us go back to our MATLAB and we will create this using a command called diag, which creates a diagonal matrix. So, 0.1 comma 0.1 comma 0.1 comma 0.2. When I give this, okay, and press enter, this is the matrix that I am going to get. And what I need to do is post multiply my all marks with this particular matrix, okay. So, all marks multiplied by this is going to give me scaled. If I pre-multiply, I am trying to multiply a 4 by 4 array with a 6 by 4 array. 4 by 4 and 6 by 4 are not commutative under pre-multiplication. So, let me try this, ANS multiplied by all marks, and let us see what I get. I should get an error, okay. Error using star, inner matrix dimensions must agree. That means the number of columns of the first guy should be equal to number of rows of the second guy. Number of columns are 4 for our ANS, but number of rows for all marks were 6. So, this is not commutative under multiplication. But anyway, this is not what we wanted. What we wanted to do was a post multiplication. I just showed you what type of errors you can expect and what that error really means, okay. So, if I do all marks multiplied by ANS, this is what I am going to get. Now, the marks are scaled out of 10 instead of out of 100, 100, 150, they are now each of them are out of 10, okay. Again, if we combine the two commands, we can combine them saying all marks multiplied by diag, okay, 0.1 comma 0.1 comma 0.1 comma 0.2 square bracket close, round bracket close, okay. Diag has one vector, that is an argument. So, there is only one single argument to the command diag, and that argument is a vector which has 4 elements, okay. So, notice that within the circular brackets I have created a square bracket, okay. So, this is going to create a vector containing 0.1, 0.1, 0.1, 0.2, and that vector is a single argument to my diag command. When I do that, I am going to get the same result, okay. And if I wanted to store this in a vector called, let us say, scaled marks, all I have to do is I go up key. When I press up key, the previous command is visible to me, and now I say scaled marks equal to all marks multiplied by diag. Okay. When I do that and press enter, I am going to get scaled marks. Okay. So, with this we come to the end of the recap for lecture 1.2. So, what I have tried to do in this particular lecture is take a simple example and go over some of the array operations that we did in the previous lecture. Okay. So, as you can see, the colon notations, how to refer to a particular row to a particular column is something that we have seen, and the final thing that we have seen is how to use some of the array operations such as sum, mean, so on and so forth. Okay. So, thank you for listening to this lecture 1-2b. I will see you in the next lecture, where we are going to cover how to use for and while loops. Thank you.